Hi, everybody. Now we're going to look at output configurations. And so what I'm sharing with you on my screen right now is the spec sheet for the inverter, for the Texas Instruments SN74LS04, so a pure inverter. And the parameter I'm looking at here is high-level output current and low-level output current. So we're looking at how much current can the gate provide if the output is high or if the output is low. And I've circled the data here. You can see that for a high level output, and the minus sign means that it's the current is leaving the chip, so it's providing that current. It can only do 0.4 milliamps. But you can see for a low level output current, so now it's sinking the current through the chip, it can actually provide 8 milliamps, which is a lot better. Okay, so this data coming from the spec sheet for the high level output current and low level output current, IOH and IOL, remember this data because we're going to use it in our next example. So let me clear the annotations here. There we go. Okay, so looking at this, we're looking at the two output configurations, and we want to look at the difference between them. So I'm showing the inverter, and I have a resistor, and then I have my LED to ground. Okay, now I haven't shown what the input of my gate is doing, but maybe you've hooked it up with a switch as we just learned, or you've tied it to either 5 volts or ground, one of the two. Okay, so there's two configurations I want to look at, and I'll draw them both here, and then we'll look at the differences between them. And let me just erase this a little bit. Clear all drawings. Stop. Uh-oh, I cleared everything. Oh no, can I get it back? Let's see. No, I lost my drawings. Okay, let me just redraw them. So I've got my two configurations. One of them, the output from the chip, is going through a resistor to an LED to ground, and the input is either to 5 volts or ground. It could be either, or to the switch configurations that we just learned. The other option is that our output is going through a resistor and is tied to 5 volts. Now I forgot to include the LED there, so let me just erase here. And so the LED is now here. There's the output of my gate. There's the input of my gate going either to 5 volts or ground. So I've got these two possible combinations, and this is my light emitting diode, right? I either have the output coming from, so if I want, in the first configuration, if I want the light to turn on, if this output is high, its voltage will be bigger than ground and current will flow like this and the light will be on. For the second configuration, it is actually the low output that turns the light on. So if I get a low on this side of the LED, that's higher than, or that's lower than the 5 volts. So the LED will turn on and the current will flow this way and through the chip, right? So the difference here is that when the current is flowing from the chip, according to the spec sheet, we could get a max of 0.4 milliamps, which is not very big. But if we wire it per the second configuration, we can get as much as 8 milliamps, which is much, much better. So if we continually try to drive an LED with our gate, it's probably going to try to pull too much current and eventually could burn your chip. So the better option is to sync the current with the chip using the second option. So this is the preferred option. And in this case, you notice that it's a low output that turns the LED on, and a high output would actually turn the LED off from the output, okay? And it's this little inverter to LED type of circuit that is actually in your green logic board that allows the LEDs to come on when you have a high from your chips. That actually goes to an inverter to create a low so that you can access this greater sinking current.